Good morning, everyone. Welcome to this live stream. I hope you can all hear me out there, and welcome. Is Michael out there? Michael should be helping me answer some of your questions, and as we go through this. What I'm going to be doing this morning is a new experiment. It's going to be 5 short questions on pure maths. So if this is successful, what I'm going to be doing is rolling out another one tomorrow and another one on Friday. And we're going to be mixing this up with some mechanics and statistics as we go along. So during this period where we're all at home, hopefully it will help keep your brain ticking over and keep you up to date. Okay, so that's the plan. Just to let you know that if you haven't seen it already, if you are on my website, you'll see in the footer there links to my diary page, or you can go in the description below the video. You'll see that there's a link there for my diary page, and it will tell you all my upcoming live streams, also when I'm going to be premiering some live videos. So I've got one this morning, by the way, 11 o'clock. If you care to join me there, I'm going to be premiering a video I made on integration 4. So it'd be great if you can join me on that. And you can ask questions as we go through the video. Okay, so so I think really if we're all out there and ready to go, I can see some guys coming in now. Good to see Michael up there. Michael, by the way, just helping me. He's from Air Maths Tuition, and he is helping me to build the GCSE side of things. So if you've got younger brother, sister doing GCSE, get them to go on the GCSE side. He's at the moment writing up some past paper work solutions for you guys. So hopefully you'll take a look at that. ExamSolutions, as you know, always been free. I'm now in the 14th year of doing this, and it's stayed free all this time, so I'm well proud of that. Okay, so thanks for any support you guys give to keep it going. Okay, well, I can see we have got quite a few people coming now online, so let us get cracking. Okay, so I'm going to take you over to the first of 5 questions, and we'll just see how we go from there. Okay, it should only be about 15 minutes, I would think, but hopefully it will help you. So here we go. We'll just bring up that first question. So hope you can see that. What we've got here is then to find the gradient of the line joining the points 2, -3 to -5, 7. So if you'd like to have a go at that, we'll just see who can give us the answer. Put your answers up online if you want to have a go. Be good to try it out. I'll bring up the answer later on, and also a few more revision notes on this. Okay, so I would say it should only take about half a minute to a minute to try and work that one out. I can see Crazio's just given us a message. Yes, I will be putting some stats out. Possibly next week. If you all right, we got some answers coming in, and Erica appears to have given us an answer. She's coming in with -10/7. Does anybody else kind of agree with that one? Let's just see. Okay, so nice one, Erica. Yep, good. Anybody else out there? Do you agree with Erica? Yeah. Okay, Crazio's -10/7. Okay, well done to you guys, because that is the answer. What I'll do now is just show you that answer and you can check out how your working's been going. By the way, you might want to come back and look at these revision tutorials later on. Okay, so they'll build up and hopefully prove to be a valuable resource. Well, you can see that I've written here how you go about working out the gradient. It's the difference in the y coordinates over the difference in the x coordinates. And you can do it a couple of ways. You can do the difference in the y coordinates, as you can see I've done down here, starting with -3, -3 minus 7, and then divide it by the difference in the corresponding x coordinates, divided by 2 minus -5, as I've done down here. And you can see that comes out as -10 divided by 7, which overall is -10/7. And I've given you the example the other way round, so you can check that out. Okay, it makes no difference, okay, which way round you do it. Got a few revision notes here, as I say, you might want to check over. We've got the reminder there of the gradient between 2 points. Don't forget, when it comes to perpendicular gradients, the product of the gradients equals -1. So if you've got one gradient, say of one line is 2, all you've got to do to have the perpendicular gradient is do the reciprocal of it, which is 1/2, and switch the sign, so it'd be -1/2. Comes from this result here. We'll be looking at perpendicular gradient questions later on in our revision things that we do. Okay, so also just a reminder here, equation of a line has this form: y equals mx plus c, m's the gradient, c's the y-intercept. Or better still, this is a great one to use, y minus y1 equals m bracket x minus x1. When you know the gradient of the point of the line, and you know x1, y1 as a point on the line. So just a quick reminder of some coordinate geometry facts on the equations of lines and that. Okay, anyway, so let's move on. Okay, we're going to go on to the next question, which is this one, number 2. Write x squared minus 8x plus 6 in this form, x plus a all squared plus b, where a and b are integers, in fact, in this question, and you've got to state the values of a and b. So again, this kind of question comes up quite a bit, and it's got many applications which I'll take you through over time. Okay, so have a go at that one if you can remember how to do it. Okay. Yeah, I see, Ramya, you're saying, can I do some P3, P4, S2 stuff in the future? The answer is yes, I can. And if you give me a thumbs up, if lots of you give me a thumbs up for thinking that these are useful tutorials, revision tutorials, then I will build those in the weeks to come. Okay, obviously I can't do it all for everyone, but I'll do as best as I can. Okay, Krasios, you've come up with x minus 4 all squared minus 10. And yep, that is right. Erica, though, has given the right answer, so to speak, because I did ask for the values of a and b. And I can see that she's come up with -4 and b is minus 10. So well done, Erica. Okay guys, I'll just show you then how this one is done if you need some further help on it. Okay, by the way, we call this type of expression when we get questions like this, it's called completing the square. I'm sure many of you most probably knew that already, but just as a reminder, if you're unfamiliar about this idea, do go on my website, check out the video tutorials there on completing the square. Okay, so what do you do? Okay, well, I've written the x squared minus 8x plus 6, and I've said it's identical, by the way. I know quite a lot of you use equals, but it's not an equation, it's an identity, okay? And so try and use the identical sign there. What do you do? Well, you put in brackets, first of all, the x, and then you halve the coefficient of the x term. That's halving minus 8, that gives me minus 4. And you square all of this bracket. And I've shown you what you get. If you were to square that bracket out, it comes to 8x squared minus 8x plus 16. And so you'll see that by taking 16 off, okay, that would now just give me the x squared minus 8x, the first two terms, and so I've then had to plus 6 on the end. And then if you clean this up, you're going to get the minus 10 on the end. And when I compare this to the form that I asked it to be written in, x plus a all squared plus b, then clearly a is the minus 4, okay, and the b is the minus 10. So well done to you guys who got that right, and hope you've been able to see how to do that in this short demonstration. Right then, let's move on. We're on to question 3. Remember, there's only 5 questions here. Shouldn't take too long. Here I've got an integral. Okay, if you've been watching my live streams just recently, you'll know that I've been running through these, okay, types. So another go at this one. Okay, the integral of 3x minus 2 then all over x to the power 4 with respect to x. So see if you can have a go at that, and wait to see who brings us up the right solution. I know some of you guys have got calculators out there. You use the Casio Class Whiz, which is a great calculator to have, and you can do quite a lot of these kind of calculations on it, okay? But I'd like to think that you're doing this without the use of a calculator, and you know, you can type out the answer for us, okay? So it's going to take a little bit longer maybe to do, but we'll run through this shortly. Okay. Yeah, I wish I was a 25-year-old person, Your Majesty, but I'm not, unfortunately. That was many years ago. I've had quite a lot of teaching experience though over these years. Over 40 years in the teaching world, so hopefully I'm able to push that experience across to you guys. And again, once again, thank you for any support you give to this project. Okay, so I've got no answers yet, maybe early days, so let's see. You can give this answer, by the way, in several forms, as you'll see at the end, okay? So we'll see what kind of answers you get. As I say, I've gone on and given a couple, oh no, three different versions for this. Okay, Maria, you've got an answer here. 3x to the power minus 1 plus 2x to the power minus 1. Maria, I don't get that answer. Good attempt though, I'm sure. It's getting close to the answer, but it's not the answer yet. So anybody else out there want to put up an answer? As I say, it's can be quite a long one. Good to work a little under pressure. We've got Erica coming in with an answer here. Minus 3x to the power minus 2 over the 2, yeah, plus 2x to the power minus 3 over the 3. Yeah, you're right. Don't forget that constant, Erica. I can see Ramia's put a constant plus c in the end there. Okay, well, answers are coming in now, and it's good to see. So, right, let's just show you what I did anyway, okay, and different variations. So, with this one, okay, you got a couple of options. You might have decided to bring the x to the power 4 up to the top, becomes x to the minus 4. Using this rule, you can see, by the way, I've written some indices laws here, just as a reminder, because with questions like this, quite often you're going to need to know these indices laws. So just a reminder there. So some of you guys might bring the x to the 4 up to the top, so it's x to the minus 4. Others of you might say, well, I can divide both of these terms by x to the power 4, and you'll get something like this. Either way, whatever you do, if you do this one and multiply out the bracket by adding the powers, etc., you should get this result. Or if you do it this way, 3x over x to the 4, subtract the powers, x to the 1, take away x to the, 1 take away 4, I should say, that's going to be minus 3. So you can have 3x to the power minus 3, which I've got there. And this one to bring the x to the 4 up to x to the power minus 4. Okay, so either way, you're going to get this result. Usual thing then for this type of integral, add 1 to the power and divide by the new power. So adding 1 to minus 3 brings us up to minus 2, divide by that new power minus 2. Same here, add 1 to the minus 4 gives you minus 3, divide by that minus 3. And then tidy up. So I've just brought the negative powers down into the denominators, okay, by this rule here, and don't forget that plus c. Now you could leave it like that. I didn't ask for any particular form. It's quite good though to write a positive term first, and that's what I've done here, okay, and then the negative term if you've got that option. Or you could make it one term here by combining those two terms, putting it over the lowest common multiple of 3x cubed and 2x squared, which is 6x cubed, and then just simplify your fraction, okay? So check that out, okay? And well done if you got that one right. Okay, let's move on now. We've had about 15 minutes here, and that's what I said this video would, or live stream session would be. It's going to take a little longer, but we've got just 2 more questions to go. So we have this one now on functions. We've got f of x is 5x squared minus 3. G of x is 2 divided by all of x minus 1. And I want you to solve gf of x equals 3. Again, quite a common type of question you get in exam papers. So have a go at that one. See how you get on. I've seen this one also at this level in GCSE papers. Michael was doing a work solution to one just the other day, and I was not surprised, but over the years, you know, the exam papers I thought had got easier, and now they're bringing in topics like this now. So useful for people doing GCSE as well. So have a go at this one, see how you get on. Okay, so it shouldn't take too long to do if you scribble it down, and I'll bring you up some revision notes as well on this one, just on functions that might be of interest when we bring up the solution. So right, we've got an answer from Ramya. That's very quick, Ramya. X is the root of 14/15 plus or minus 14/15. Is that right? Well, let's just hold back and see. Does anybody else come up with any answers? And we'll see if Ramya is right or not. Okay. So I see okay, how are we doing out there? Should have been able to combine those functions. I'm going to give you the fact that if you combine the functions, you're going to get 2 all over 5x squared minus 4, and then you should be able to take it from there. Din has come in with an answer of plus or minus root 14/15. So I think that seems to be the right solution. Erica, you've got 8 over 15 to the power half, the root of 8/15. You've obviously tripped up somewhere. Okay. Right, Right, I'll go through this, but well done guys for having a go out there. So let's bring this up. You'll see I've got some stuff here on the right hand side just on functions. We'll be talking about inverse functions in another revision tutorial. I'll give you some questions on that. But for now, let's move on quickly. Gf of x, okay, equals g of f of x, okay, f of x being 5x squared minus 3. So all I need to do now is substitute 5x squared minus 3 into g of x. Wherever I see an x, just write 5x squared minus 3, which is what I did down here. Simplify it and you're going to get 2 over 5x squared minus 4. And then we set gf of x equal to 3. Our equation here equal to 3. Multiply both sides by 5x squared minus 4, leads into this equation. Expand the bracket and then just rearrange it. And you'll see you get 15x squared equals 2 plus 12, which is 14. Divide both sides by 15 and then you're going to square root and get plus or minus the root of 14/15. Not a nice answer, but nonetheless just one. Okay, right, okay, so let's move on. Last question, guys. So here it is. Arithmetic progressions, a bit of revision here. The 6th term in an arithmetic progression is 20 and the 7th term is 15. What is the first term? Okay, so give you a few moments there. Hi Peru, 548. Okay, nice to see you join us. Okay, so see how you go with this one. We should be finished soon. Okay, we'll wind this up and that'll be our 5 a day done. Okay, so I'm looking for that first term. Okay. Okay, Ramya, we've got A is 45. Anybody else out there want to agree with Ramya? Kumaresh, you've got 45 as well. Well done. It is 45, so excellent stuff. You're very quick at doing this, so hopefully this does give you good practice. So let's just run through this and wind this up. Okay, so you should have seen that the common difference, that's the first thing you've got to work out, given by the letter D. And I've given some notation down here that we use in arithmetic progressions. And Sn, by the way, is the sum of the first n terms. Okay, n over 2, all times a plus l. And you could use the sum of the first n terms as this formula here as well. Okay. Again, later on in some more revision tutorials, we'll be, I'm sure, I'll be setting you some questions on all of this stuff. Okay, so for now, you've got to know this formula. The nth term is a plus n minus 1 times d. And you can do this 2 ways, as you'll see here. I've taken that when n is 6, the 6th term we're told is 20. So by substituting those values into the formula here, you can see a turns out to be 45. You might not have gone for that method. You might have said that looking at the 7th term, which was 15, n is 7, substitute that into this formula. You can see it still works. A is 45. Okay, so well done to all of you who have taken part in this. Thank you for coming along and having a go. If you've enjoyed this and found it useful, before you leave, I'll be really grateful if you give us a thumbs up. And don't forget, look in the description below the video and you should find that there's a diary there that you can go on and you'll be able to see live streams that I've got coming up. And I'll be adding to this. There'll be more coming up next week as well. Okay, so keep coming back to that. That leads me to say thank you. Thank you to Michael for helping us out here. And hopefully see you again. And by the way, just to remind you, yes, I'm on again at 11 o'clock. Only it's going to be a video premiere of Integration 4. Okay, so do check that out. Okay, you can see, as I say, a link in the diary below the description. So bye for now. Have a great day, and don't get caught out, by the way, on any April Fool's jokes. Okay, see you later.